Hi there. We looked today at finding the volume of a known solid, right? So not one that we are generating by revolving around an axis of revolution, but it's a solid that's already been created. We're going to find its volume given a particular cross-section. Our shaded region in this case is going to be the base of that 3D shape. And so then the upper minus lower that we've been finding for area and volume is going to become one side of that cross-section. Okay, so we have some formulas here, area formulas, and again this worksheet, this notes sheet is on my website, so feel free to download it and follow along, stopping the video if you're feeling like you're getting it and want to give it a shot on your own. Okay. Our boundaries in this case, x equals 0, y equals x squared plus 1, y equals 1, and x equals 2. If we graph those, put them in our graphing calculator, we have x equals 0, y equals x squared plus 1, y equals 1, and x equals 2. So this is my shaded region. The known cross-section is an equilateral triangle, and it's perpendicular to the x-axis. So when I draw in my representative side here, it's going to become parallel to the x-axis, which means our formula, or our integral, is going to be dx. So our bounds are going to be the smallest and largest x in our shaded region. Our smallest x is 0, our largest x is 2, right? This is x equals 2 here. Smallest x to largest x, 0 to 2. And then it's an equilateral triangle, so I'm going to be using this formula, root 3 over 4 s squared. So I have root 3 over 4 s squared. And my s is the side of the equilateral triangle. Well, this here, my representative side, is the side of an equilateral triangle. And if I want to find that distance, it's upper minus lower. My upper sits on x squared plus 1. My lower sits on 1. So upper minus lower. Just the same thing. Root 3 over 4 as just, because 1 minus 1 is 0, x squared squared, which is x to the 4th. So then we add 1 to our exponent, divide by our new exponent, or plug it into your calculator to help you double check your work. And f of b minus f of a, we get root 3 over 4 times 32 over 5, plugging in the 2, minus root 3 over 4 times 0 over 5, plugging in the 0, which this is just 0. Here we get 32 root 3 over 20, which is the same thing as 8 root 3 over 5. Okay. Number 2, we have our boundaries y equals root x, y equals 0, and x equals 4. There's y equals root x, y equals 0, and x equals 4. Okay. In this particular case, we're doing semicircles perpendicular to the x-axis. So I'm going to go ahead and draw in the base of my semicircle there. Perpendicular to the x-axis. This is perpendicular to the x-axis. We're going to be doing it in terms of dx, the integral that is. And then the area formula for a semicircle is 1/2 pi r squared. Because we're doing it in terms of x, so dx, my bounds need to be the smallest and largest x values. Well, my smallest x over here is 0, and my largest x is 4. Right, from 0 over here to x equals 4. Radius is half a diameter. So right here, this is my semicircle, right? And so it's a little hard to visualize, but if you can visualize coming out of the top of this shape, right, 3D, so coming towards the camera, away from the paper, we have this semicircle popping up, right? And so with that semicircle, this is my diameter, upper minus lower. Upper is on my root x, minus my lower, which is 0. But that's the whole thing, right? That's the entire distance. Upper minus lower is root x minus 0. I want the radius, and so I'm going to divide by 2, right? Because radius is half a diameter. Okay, so this is the same thing as 0 to 4 of 1/2 pi. Root x minus 0 is just root x, and root x squared is x. 2 squared is 4. Which is pi over 8, right? 1/2 times pi times 1/4 is pi over 8, x dx. Okay, so we add 1 to the exponent, divide by the new exponent, so we have pi over 8, x squared over 2, from 0 to 4. From 0 to 4. And then f of b minus f of a, we plug in the 4. We get 16 pi over, 8 times 2 is 16, minus, plug in the 0, 0 pi over 16. Well, 0 pi over 16 is 0, and 16 over 16 is 1, so we're left with pi minus 0, which is pi. Okay, number 3, we have x squared plus y squared equals 9, which is a circle with radius of 3. So this is up here at 3, negative 3, negative 3, 3. Shaded region. Now my rectangles are going to be, they're going to be rectangles, by the way, perpendicular to the y-axis with height of 2. So to the y-axis, so now my rectangles go this way. And since we're to the y-axis, my integral is going to be dy. And my bounds are going to be the lowest and highest y. Well, the lowest y is down here at negative 3, and the highest y is up here at 3. And then a rectangle is base times height. Base times height, in this case my height is 2. Okay, and I actually probably am going to need to give myself a little bit more room, so I'm going to go ahead and rewrite this a little bit further out here. Base times height. Okay. So my base is upper minus lower. So my upper out here is touching this edge of the circle. Well, our circle is x squared plus y squared equals 9, but that doesn't do me any good when it comes to plugging it into my integral. I need to have y's being used in my equation because I'm going to be taking the integral with respect to y. So I'm going to go ahead and solve for my x here. I'm going to subtract the y squared over. So I get x squared equals 9 minus y squared. And then I'm going to take the square root of both sides, and so I get x equals plus or minus root 9 minus y squared. So this point here is either sitting on the positive root 9 minus y squared or the negative root 9 minus y squared. Well, this point is over here in the positive region. It's in the upper region, and so this is my positive root 9 minus y squared. Minus my lower, this point sitting in the negative region, so this is the negative root 9 minus y squared. So upper minus lower. Minus a negative is the same thing as plus, so we're negative 3 to 3 of root 9 minus y squared plus root 9 minus y squared, which is 2 root 9 minus y squared. Right? Well, 2 root 9 minus y squared times 2 is 4 root 9 minus y squared dy. So when we pick up our calculator and we plug that in, we're doing 4 root 9 minus y squared dy from -3 to 3. We should get 18 pi. Now in this particular case, we are not adding the pi in, right? The pi is there because this originally started as a circle, right? Okay, last one, number 4. We have f of x equals x. We have g of x equals x squared minus 2. Okay. And our cross section, I just realized there was a typo here. This should say cross section. Integral, we're doing squares, so that's going to be our s squared, and then we're doing it with respect to the y-axis, so this is going to be dy, and my bounds are going to be my lowest and highest y. Well, my highest y is at that point, and the y value of that point is 2. And then my lowest y is at that point, where x equals 0. And where x equals 0 of my quadratic is at -2. Big R, or sorry, upper minus lower, not big R and little r. We aren't revolving. It's already been revolved. We're just cutting it up. So we just need to show our side of our square. We have our upper minus our lower. Our upper sits on x squared minus 2. But I don't want x squared minus 2 because I'm doing it with respect to y. And so I need to change this equation into terms of y. So I'm going to go ahead and add this 2 over, so I get x squared equals y plus 2, and then I'm going to square root it. X equals plus or minus square root y plus 2. So now my equation's in terms of y. This upper sits on the positive portion of that graph, so y plus 2 minus my lower, which sits on y equals x. And so then we pick up our calculators, we plug that in. We have our square root y plus 2 minus y dy from -2 to 2, and we should get 16 over 3. That is not correct. Where did I make my, oh, sorry. Let's try this again. Square root y plus 2 minus y, quantity squared. Right? I forgot my squared here when I plugged it into my graphing calculator, so make sure we're always aware that it should look like, this is what clued me in when I looked here, this was not the same as what I had written on my paper. I missed the squared. So I'm going to go ahead and add that squared in. And it equals, there we go, 136 over 15. Right, because now this looks like my paper. Integral -2 to 2, y plus 2 minus y, all squared. You should get 136 over 15. And there's my answer.